All right, guys, this is note card 10. Here's some basic derivative rules. So we learned in the last note card the formal definition of the formal definition of derivative. It looked like this. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. And we saw what a pain it was to use this actual definition to calculate a derivative. Now let's talk a little bit about notation. So there's some different ways that we can write derivative. One of them, all right, is if we say f prime of x, that means derivative. Okay, and that's what's called the Newton notation. Okay, Sir Isaac Newton came up with that. All right. Now, another way we can write a derivative is something that looks like this, dy over dx. It means the derivative of y with respect to x. All right, and this is known as the Leibniz notation. I'm not sure if I spelled Leibniz correctly, but a guy named Leibniz also kind of came up with the same ideas as Newton around the same time. So we're not exactly sure who invented calculus or who discovered calculus. Okay, but these are the main two that are credited with calculus. So if you see this type of notation, or if you see this type of notation, they both mean the same thing. We're looking for the derivative, or the derivative function, or the derivative at a point. Okay. Remember, derivative is nothing more than the slope of the tangent line. Okay. Or another way to say that is the instantaneous rate of change, or how fast you're going at a specific moment in time. You look down, you're driving in your car, you look down at your speedometer, and at that exact moment in time, that's your speed, or that's your average rate of change, or your instantaneous rate of change. Okay, so let's learn some properties here. Let's learn these rules. All right, so derivative rules. The derivative of a constant, okay, C just stands for constant. So an example would be if f of x equals 32, the number 32 is just a constant. If that's true, then the derivative of that would be 0. If you want to think about y, if you were just to graph the function 32, up here at 32, it would just be a horizontal line. Now, why is the derivative 0? Because at any point, if I were to draw in a tangent line, at any point, the tangent line would be simply horizontal. And the slope of a horizontal line is 0. That's why that's true. Okay. The next rule is called the power rule. Okay. So let me give you an example there. So let's say that f of x equals, I don't know, x to the 7th power. To find the derivative of this function, you move this power, 7, it comes to the front, okay, and then you reduce the power of 7 by 1, so that would be 7x to the 6th. And that's what the power rule does for us. Now, the constant multiple rule says, let me give you an example of that. If you have a constant in front of some other function, okay, then or it's not a constant, it's a coefficient. C stands for a coefficient here. Okay, then that coefficient stays and you take the derivative of whatever f of x is. So for example, if this rule is really useful if you have something like this. If h of x equals 5 times f of x, okay, then h prime, that 5 would stay, but then you would multiply that 5 times the derivative of f. Or let me give you another example of that. So let's say you have g of x equals 6x cubed 6 times x cubed, then g prime of x would equal that 6 would stay, and then you would take the derivative of x cubed, so the 3 would come out front, and you would reduce the power of 3 down to 2. Then you could simplify if you'd like, so that would be 18x squared. So there's another example of it. Now the sum and difference rule, let me give you an example of that. If you have two different functions or two different pieces, u and v, okay, if you add or subtract that, then you would just take the derivative of each one. So, for example, if p of x equals q of x plus r of x, then p prime of x would equal q prime of x. You would take the derivative of q, and then you would follow the same sign, so that would be plus again, the derivative of that. In a more practical sense, let's say that p of x equals, I don't know, x to the fourth minus x to the third. To find p prime, you would take the derivative of the first term, which would be 4x to the third power. You would do the same sign, so you put a minus, and then you would take the derivative of x cubed. So the 3 would come out front, and you would reduce the power by 1. Okay, so with pluses or minuses, you just take the derivative of each piece. All right. So let's work some example problems now. Let's use these rules. Okay. So in number 1, they're telling me this is the original function. Okay, but they're asking me what's the derivative evaluated at an x value of 4. Well, the easy way to do that without using the definition of derivative is let's first find out what f prime for all of x is. Okay, so this is a power. It moves out front. Now you have to reduce this by 1. So you have to take 3/2 and subtract 1. Okay. So you got to be careful here. When you take 3/2, remember 3/2 is like 1 1/2. 1 1/2 minus 1 is just a half. Now that's kind of hard to write. How do you write fractional exponents? Well, x to the 1/2 is the same thing as saying the square root of x. So this is actually, you could write it either way, but that's what the derivative function is. Now we're not quite done with the problem yet, because they want to know what's f prime at 4. So here's my derivative function. I'm going to plug in 4 where I see the x. So I'm going to take 3/2 times the square root of 4. I'm going to simplify it. What is the square root of 4? Well, it's just 2. And here these 2's cancel. Okay, so my answer there, my final answer for this problem is simply the number 3. So what's the meaning of that? On this curve, if I drew in a tangent line to this curve at a value of 4, then the tangent line would have a slope of 3. So I'm just going to show you that on a calculator so you believe me. Okay. So I'm going to say x to the 3/2. I'm just going to do a zoom standard. So that's what the graph of x to the 3/2 looks like. All right. And then, so let me make that in red. Now, I'm going to quit out of here, and I'm going to go second. Then I'm going to hit the program button, because above it, it says draw. I want to draw on a tangent line. I'm going to draw on a tangent. I'm going to draw on a tangent to what I have in y1, and I want to do that at an x value of 4. Hit enter. Okay, so what the calculator did, it drew in a tangent line. All right, and the slope of this line right here would be 3. Okay, the slope of that line would be 3. Another way I could do that, let me just make this a different color real quick. So there's the graph. There's a way in the calculator to get an approximation for the derivative at a point. So if I hit second trace, the word CALC is above in blue. Okay, if I go down to option 6, this is the notation for derivative. So I'm going to hit number 6 or go down to 6 and hit enter. And if you have the newer model of this calculator, it says calculate the derivative at a point. Well, I want to calculate the, excuse me, the derivative at a value of 4. So I'm just going to type in 4, and I'm going to hit enter. All right, and right here, the calculator tells me the derivative at that point, if I drew in a tangent line, right where that cursor is, if I drew in that tangent line like I drew before, the tangent line would have a slope of 3. So it's a way to verify. Okay, it's a way to verify. This is a numerical approximation for the derivative. Now, what's this other information? That's actually the point on the curve. When the x is 4, the y is 8. So if I plugged in 4 to the original, it would come out to a y value of 8. Okay. So number 2 is a little bit harder. All right. Here it says f of x equals 1 over 2 times the cube root of x squared. It's going to be really hard to find the derivative when it's written like this. So I'm not going to take any derivatives yet. All I'm going to choose to do is I'm going to choose to rewrite this radical piece as a fractional exponent. So I can write that as x to the 2/3 power. Okay. Now, what I can also do, I can move this part up into the numerator by changing its sign. So instead of x to the positive 2/3 power, I can do this instead. I can say 1/2 times x to the negative 2/3 power. What I've essentially done is I've taken this and I've moved it up into the numerator. When f of x is written like this, now I can use some of the rules up here. I can use rules 2 and 3. So I actually want to take the derivative of that if I want to find f prime of x. Okay, the 1/2 would stay. Now I would use the power rule, and I can move that negative 2/3 out front. X, now I have to subtract 1 from here. So negative 2/3 minus 1. So I need to raise it to the negative 2/3 minus 1. But what's 1? It's the same thing as 3/3. So f prime of x would equal, well, let's go ahead and multiply those two together. These 2's cancel. You have 1 negative over 3, so that turns into negative 1/3 as the coefficient. X, negative 2/3 minus 3/3 is negative 5/3. So this is an acceptable answer for the derivative. Now, if you don't like the way that's written, you could also write it like this. I can write it as negative 1 over 3. I can send this x to the negative 5/3 to the denominator and make it into a positive power. So I could write it like that. That's an acceptable answer. These are both equivalent to each other. Or I can rewrite it even as a radical. Okay. I could say f prime of x equals negative 1 over 3 times the cube root of x to the fifth. Now on the AP test, if this is a free response question, they don't care what form it's in. But if this is a multiple choice question, they might have any of these three forms as the correct answer. Okay? Most likely they would not have this one. Usually AP does not like to use negative exponents. So more likely it would be written in one of these two ways. So you do have to know how to move back and forth. All right, number 3. Now, instead of using f of x, they're using a and t as their variables. It's not a big deal, okay? So I'm just going to rewrite this a of t real quick. I'm going to say a of t equals, well, this is the same thing as saying negative 1/2 t to the fourth, because there's an understood 1 right there, plus 3t to the third minus 2t. And then I can take a derivative fairly simply by using some of those rules. Take the derivative of the first term, the negative 1/2 stays, but the 4 comes down. All right, so I have negative 1/2 times the derivative of t to the fourth, so that would be 4t to the third. All right, plus 3 times the derivative of t cubed would be 3t squared minus 2. Now think about what this is. This is really t to the first. So when I move, I do the 2, but the 1 comes down. So I get 1t to the 0th power. So you'll see what happens here in a second. So negative 1/2 times 4 would be negative 2, so negative 2t cubed. 3 times 3 is 9, so plus 9t squared. Okay. Now negative 2 times 1 is negative 2, but be careful here. T to the 0th power is just 1. So it's just like I'm multiplying by another 1. So whenever you have like a negative 2t, the derivative of that is just the coefficient. Okay, it would just be minus 2 at the end. So here's my final answer. This is the derivative. Okay. All right. Now number 4, it's a little bit different notation. They're saying, what's the derivative of this thing at an x value of negative 1? In other words, they're saying if f of x equals 1 over x cubed minus 1 over x plus x squared, this is like what they're asking. If f of x equals that, then what is f prime evaluated at negative 1? That's another way they could have asked the same question. Okay, so let's figure out what the derivative is first. But before we do that, let's rewrite f of x a different way. So 1 over x cubed, I can write that as x to the negative third. Minus, I can rewrite 1 over, remember this is like x to the first, so I can rewrite that as x to the negative first. Okay. And I have an x squared at the end. That's just a different way to write f of x. That's going to be easier to take a derivative. Now I can find the derivative fairly easily. So the negative 3 will come out front. I'll subtract 1 from the power. Okay. All right. Now watch how I do this next one. There's an understood negative 1 here. That's the coefficient. Basically, the power rule, you can just multiply those together and save a step. So negative 1 times negative 1 turns into positive 1, but I still need to reduce the power by 1. And then the derivative of x squared would just be 2x. 2x to the first, which is still 2x. Now if I wanted to rewrite that a different way, I could say negative 3 over x to the fourth, put it back into the denominator because it's the negative power, plus 1 over x squared. Again, negative exponent, just put it back out into the denominator, plus 2x. So this is the easier way to deal. This is what the actual derivative is for all of x, for any x value that you give me. They want to know what f prime, what the derivative is evaluated at -1. So I'm going to take this function right here, and everywhere I see an x, I'm going to plug in a -1. So I have -3 over -1 raised to the 4th power, plus 1 over -1 raised to the 2nd power, plus 2 times -1. Now I'm just going to simplify that. So -1 to an even power will be +1, plus 1 over -1 again to an even power will be +1, and 2 times -1 would be -2. Okay, so -3 over 1 is -3, 1 over 1 is 1, and I have a -2 at the end. And then if you just combine those, -3 plus 1 is -2, minus another 2 is -4. So that's the answer. This is the derivative function, and this is what the derivative is evaluated at an x value of -1. So this curve, this original curve, if I drew in a tangent line at an x value of -1, the tangent line would have a slope of -4. Some more practice here on the back. It says find g prime if this is what the actual starting function is. Okay, you got a -3 over 5. I'm just going to bring that out front as the coefficient. I got x cubed, then I got a minus 4x squared plus 7x minus 6. So I just rewrote the function. Now I'm going to take the derivative. Okay, I'm going to take this number, -3/5 times that number, just an easier application of the product rule, or the power rule, excuse me. -3/5 times 3, remember this is like 3 over 1. That's going to turn into -9. -3 times 3 is -9. 5 times an understood 1 is 5. And then I'm going to make the power of 3 go down by 1. Okay. For the next term, I have a -4 times 2. That's -8. I'm going to make the power go down by 1. Okay. So 2 is going to turn into 1. In the next term, I'm going to take the +7 times 1, so that's plus 7, make the power go down by 1. And the derivative of a constant is 0. The derivative of -6 is just 0, so I don't even have to worry about that. And what is x to the 0th power? It's an understood 1. So if I replace this thing with a 1, it's just 7 times 1, which would be 7 still. Okay. So here, g prime of x simply equals -9/5 x squared minus 8x, x to the first is just x, plus 7. So that's what the derivative is. Okay. Next problem, just another way. Remember that means derivative as well. Okay. So let's write this a different way. The first term has an understood coefficient of 1 right there in the numerator. So I can rewrite p as 1/3 t to the -4th minus, again, 1/9 t to the -3rd plus t squared minus 5. Okay, I just rewrote the function. I haven't taken any derivatives yet. Now I'm going to take a derivative. The derivative of p with respect to t. So I'm going to take the derivative of this. So I'm going to take the 1/3 times the negative 4. That would be negative 4/3. I'm going to make that go down by 1. Now on the next one I have negative 1/9 times negative 3. Okay, negative times a negative is positive, so that would be plus 3/9. Make the power go down by 1. Right. Plus, there's an understood 1 there. 1 times 2 is 2. T to the first, make the power go down by 1. Again, I took the positive 1 times 2, so I got the 2, and made that power go down by 1. Minus derivative of a constant is 0. Don't need that part. T to the first is just t. Okay, so I don't really write it that way. So I can write it this way now. Negative 4/3 t to the negative 5th. I can simplify 3/9. 3/9 is 1/3 t to the negative 4th plus simply just 2t. Or if you wanted to, you could get rid of the negative exponents by moving them. So I can write this as negative 4 over 3t to the 5th plus 1 over 3t to the 4th plus 2t. Now, one thing they could do, they could take this and get a common denominator. So I'll just show you one of those. All right, so if I wanted to get a common denominator, right, this is 3t to the 5th, this is 3t to the 4th. So to get it up to t to the 5th, I need to multiply by another t. And then here I still need to make this into 3t to the 5th, so I have to multiply the numerator and denominator both by 3t to the 5th. So this also could be written as something like this to get a common denominator. Negative 4 plus 1 times t, that's just t. 2t times 3t to the 5th, 2 times 3 is 6. T to the first times t to the 5th would be t to the 6th. Okay, all over the common denominator of 3t to the 5th. So they could present the answer like that too. So just be aware, they might choose to get a common denominator. Probably not though, probably the original red answer is what you would be getting there. Now number 3, they're telling us what f of x equals. Okay, here's the function, here's the inside function. They're just writing it a different way. It means find the derivative of this function. So 6x to the 4th minus 3x plus 14 all over x squared. What I can actually do with this is I can break it up. I can take each term in the numerator, each of these 3 terms, and I can divide each one by x squared. That's allowed. Okay, because this is just the reverse process of getting a common denominator. So I could write the function like that. Now you could actually simplify. Okay, 6x to the 4th over x squared. 2 of these cancel 2 of these. So I would have 2 left. So that first term is just going to turn into 6x squared. Okay. Now we haven't taken any derivatives yet. I'm just rewriting the function. Well, here, one of these x's cancels out 1 here. So you have just minus 3 over x. Okay, and in the last term, you don't have any x's in the top, so it doesn't cancel with any of those. But now what I can do is I can rewrite that again, and I can write it like this. 6x squared minus, well, I can move that x up to the numerator by making it into a negative power. Okay, so I can write that as minus 3x to the negative first, plus 14x to the negative second. Now, why do I go to all that trouble to rewrite the function? Because taking its derivative is going to be a lot easier using the derivative rules. Okay, so now I'm at the derivative stage. 6 times 2 is 12. Reduce the 2 power down to 1, so that's just that. Would be 12x would be the derivative of this term. Negative 3 times negative 1 is positive 3, but reduce the power by 1. Okay. 14 times negative 2 is negative 28. Reduce the power by 1. So here's one possible answer for the derivative, or you can rewrite it a different way. You could say 12x plus 3 over x squared minus 28 over x cubed. You could write it like that. Okay. Or you could go crazy and even get a common denominator. Common denominator is x cubed, so multiply all of these, make it work out to become x cubed on the bottom. Okay, so that would end up being 12x to the fourth. All right, plus 3x minus 28, if you got a common denominator. Okay. Most likely that would be the answer that would be given if it was multiple choice. Okay. Number 4 here, let's rewrite the function so we can easily take the derivative. Okay. So I have 10 over 3 times, instead of writing a radical, this would become t raised to the 5-fourths power. It's the number inside over the index, so it's 5/4. All right, minus 1t to the 2/3. Okay, now I'm going to write it like this. 10/3, I'm just going to take this part, the coefficient. Now this t to the 5/4 is in the denominator. I'm going to move it to the numerator and turn it into a negative power like that, or off to the side. It means the same thing. So I have just rewritten the function itself. Now we're going to take the derivative using our rules. So I need to take this 10/3 and multiply it times that power, negative 5/4. But I have to reduce this by 1. So I have to go negative 5/4 minus 1, but what's 1? It's 4/4. Okay. Minus 1 times, move the 2/3 out front, and reduce 2/3 by 1. But what's 1? It means the same thing as 3/3. So we can do some cross simplifying here if we want to make this a little bit nicer. All right, if you think about 10 and 4, that can be reduced to 5/2. So what do you have? You have 5 times negative 5, that's negative 25. 3 times 2 is 6. Negative 5/4 minus 4/4 would be negative 9/4. All right. Negative 1 times 2/3 is negative 2/3. All right. Now when we do the subtraction, 2/3 minus 3/3 is negative 1/3. So you could write the derivative like that. And if you kept simplifying, you could also do it like this. You could move this negative exponent back to the denominator. So you could say negative 25 over 6 t to the positive 9/4 minus 2 over 3, and again, negative exponent, you could move it back down to the denominator. So you could write the derivative like this. Or you could even write it back with radicals. Negative 25 6 times the 4th root of t to the 9th power minus 2 over 3 radical. This would be the cube root of t to the 1st, but you don't really need to put t to the 1st, that's just t. So you could write it like this, or you could even get a common denominator, but this one could get tricky. There's a lot of different ways you could write it that would still be correct. You just have to know your algebra operations. Okay. The biggest thing with these problems is just to take your time. Okay, do one step at a time. Rewrite the function until it's something you can take a derivative of using these rules that you're learning. Okay, and then maybe simplifying it in different ways. So getting practice doing that. Okay. There's a few more. All right, so find the derivative for this function. Okay, now they're using y's instead of f of x's, no big deal. So the first thing I want to do is I want to rewrite the function to something I can take a derivative of. So this is going to become negative 3 over x to the 2/5 power. That's what that radical is. Plus square root of x really is this. It becomes x to the 1/2 power. If you don't see an index on a radical, we assume it's 2 over 4. And there's also an understood coefficient of 1 there in front of the radical. Okay, minus 7. So I'm going to keep going. I'm going to keep writing this in a way that's going to be easy to take a derivative. I can move this x to the 2/5 up to the top as long as I change the sign on the power. So it's negative 3 x to the negative 2/5 power. All right. On the next term, I'm just going to take the 1/4 coefficient, move it out front, x to the 1/2 minus 7. It's going to be easy to take a derivative from there, or easier. So now I'm going to say y prime. Now I'm going to take the derivative. So I'm going to take negative 3 times negative 2/5. Well, negative 3, this is like negative 3 over 1. So negative 3 times negative 2 is positive 6. 1 times 5 is 5. Now we got to make this go down by a power. So I'm going to take negative 2/5 and subtract 1. Remember, 1 is like 5/5. So negative 2/5 minus 5/5 is negative 7/5. Take the derivative of the next term. Take this 1/4, multiply it times 1/2. 1 times 1 is 1. 4 times 2 is 8. Now you got to make the power go down by 1. So what's 1/2 minus 1? It would be negative 1/2. Okay. This is a constant. Derivatives of constants are 0. And technically we don't need that. Right. So this is one acceptable answer for the derivative. Probably not going to appear that way. Anything with negative exponents, move them. This is off to the side, which also means it's in the numerator. Move it to the denominator. So it's going to move to the denominator and it's going to turn into a positive 7/5. Same thing on the next one. We can turn that into x to the 1/2. This is a more likely answer that would appear. Or you could write it with radicals. Six over 5 times the 5th root of x to the 7th plus 1 over 8 square root. You could put the 2 as an index there, but you don't have to. Inside you put x to the 1st, but x to the 1st is just x. So it could be written like that as well. Any one of these three answers, in terms of like a free response, leave it. However, this is a free response question. Don't simplify and simplify incorrectly, because then you'll lose points. If it's a free response question, leave it like that. Okay, this is what we call a first line answer. And it's okay to stop there on a, if it's an open response question. If it's multiple choice, this answer is probably not going to be there. It'll probably be presented in one of these two ways. All right, so 6 is a review question. I want to know what the horizontal and the vertical asymptotes are. Okay. So let's deal with part A first. How do we find horizontal asymptotes? Okay, well, a horizontal asymptote is basically going to be equal to the limit of f of x as x approaches positive or negative infinity. So we're going to use our Bobo, Betsy, and Botu. There. So let's look at it. The highest power in the numerator is 2. The highest power in the denominator is 3. Both of these are polynomials. Okay? So we are comparing like things. Okay? So here, it's bigger on bottom. It's bigger on bottom, so it's going to be Bobo. So the horizontal line that it's going to approach is simply y equals 0. That's the horizontal asymptote. Now we have to find the vertical asymptote. And to do that, we need to do some factoring. Okay, so if I do some factoring here, let's think about this. All right, if I want to do some factoring, if I factor the numerator, how do I get 2x squared? I have to have a 2x times an x. All right. And so first times first has to give me 2x squared. Last times last has to give me 4, but the inners and outers have to combine to give me 9. So the only way that's going to happen is if I put the plus 4 there and a plus 1 there. So 2x squared, got that. 1x, this would be 8x. If I multiply 1x plus 8x is 9x. 1 times 4 is 4. Now what can I do in the denominator? I can do some factoring there too. Okay, all of these terms have 2x in common. So if I factor out a 2x, I get an x squared plus an x minus the 12. And you can factor this quadratic some more. So I'm just going to show you how I would keep factoring here. Okay, so this thing right here could be factored into x plus 4 times x minus 3. All right, now it's asking me where the vertical asymptotes are. So what values would make the denominator 0? Okay. What about this term? 2 times what would equal 0? X equals 0 is a vertical asymptote because if I plug in 0 there, this term becomes 0 and the whole denominator would be 0. Because 0 times anything is still 0. What about this one? X minus 3. What number minus 3 would give me 0? Hopefully you say x equals 3. If x was 3, then this parenthesis would turn into 0, and 0 times anything is still 0. So these two values are the vertical asymptotes. Now you might be asking, why isn't -4 a vertical asymptote? Well, the reason it's not is you have an x plus 4 factor in the top and an x plus 4 factor in the bottom. These actually knock each other out. So that's why -4 is not a vertical asymptote. At x equals -4, there's going to be a hole in the graph. But it's not a vertical asymptote. It's a hole, or it's more formally known as a removable discontinuity. Okay. So there's no vertical asymptote at -4, but there is going to be a hole in the graph because it canceled out that factor, but still this value is excluded from the domain. And technically on this, if you typed in -4 here, you get 0 over 0, which isn't allowed. So that's why there's a hole in this graph. So my answers are y equals 0 is the horizontal asymptote, and the two vertical asymptote lines are at x equals 0 and at x equals 3. But this is not a VA. It's simply a hole or a removable discontinuity. Now number 7. I say, okay, here's my function. And I want to find the derivative, but evaluated at -3. So before we can even take the derivative evaluated at -3, I first have to figure out what the derivative is. But there is a shorter way to do this that we'll learn eventually. That's called the chain rule. But for now, what does y equals this thing squared mean? It means this times itself twice. Okay. So if we FOIL this, 2x times 2x is 4x squared. If we do the outers, 2x times -3 is -6x. -3 times 2x is another -6x. And then -3 times -3 is a +9. So y, another way I can write y is 4x squared. These two combine to give me -12x plus 9. So this is what y is. That's just a different way to write y. Now let's find the derivative of that. Let's figure out what y prime is for any value of x. Well, let's just use our rules. 4 times 2 is 8. Reduce the power by 1. So 8x to the first. There's an understood power of 1 there on that x, so -12 times 1 is -12. We reduce the power by 1, x to 0. This is a constant. Derivative of a constant is nothing. Technically, we don't need that. X to the first power is just x. X to the 0 power is the same thing as saying 1. So -12 times 1 is simply -12. So that's the derivative for any x value. That's the derivative function. Now we want to figure out what y prime of -3 is. So I have the function, just plug in -3 where we see the x. There we go. Y prime at -3 is -36. There's a way you can check it. Okay. If I put in the original function, 2x minus 3 squared, oops. This is Zoom standard. If I go second calculate, option 6, calculate the derivative at a point. If I type in -3 here, okay, that thing right there, -36, that is the derivative at that point. The actual point itself is -381. That's way up here. Okay. But if you took the slope, if I drew in a tangent line right at -3, that tangent line would have a slope of -36. Really, really steep going down. So I know there's a lot of practice on this. You got to get really good with these rules. Okay. Now the homework for tonight, you'll have an opportunity. You have quite a few problems on here. You got about 19 problems. Try to use your rules and simplify these. You have to do these. You can do these on the back of this sheet, okay, or you can do them off to the side. But there's 19 problems, so just work through those. Thanks for watching.